Okay, let's look at one more example of working with vectors and their applications. So on a sunny day, two sailing boats, the Rab and the Padge, were spotted from a lighthouse. The courses of the boats from the moment they were spotted can be given by the equations. And so we notice that that our equations seem to be given in a slightly odd way, and we're going to discuss that concept, and that the values are going to be just in two dimensions. That in the third dimension, let's say in the z dimension, that usually represents altitude if we're on a two-dimensional, flat plane, and then the going up from that flat plane be the z direction. This seems to be that we're just working right on this flat water. So units are in kilometers, parameters represent the time in hours. So let's look at what we have and just translate initially that our equation for our r vector, our Rab, is going to be -1 in the x direction as a point and 10 in the y direction as a point, and then plus a parameter of t, and I have 2 in the x direction and -2 in the y direction. All right, and then for Padge, we have 0 in the x direction as its initial point, 4 in the y direction as its initial point, parameter s, and 2 in the x direction, 3 in the y direction. So we want to show that the distance between the boats when they were spotted was root 37, right? So how do we find that distance? Well, we need to look at that distance is going to be the square root of their directional vectors. So to go from -1 to 0, I have a positive change of 1. To go from 10 to 4, I have a negative change of 6, right? But really it just cares about the magnitude of it. And so we know that that's going to be the square root of 37. And so we've shown our distance, right? That we understand it's the change in x and the change in y. Determine the exact speed of each boat with units of measure clearly indicated. So our exact speed is going to be based on the change in position over time. And notice that we're told we're working in kilometers per hour. So the speed for, so our speed, if we think about it for the Rab, is going to be given by, right, my change in position, which will be 4 plus 4, which is a square root of 8, right, and that's going to be kilometers per hour. And the speed of the Padge, right, that's going to be the square root of 4 plus 9, which is root 13, and that's also going to be kilometers per hour. Now you might say, well, why was it that simple? Well, if t is representing hours, right, and this is what I'm changing in terms of 2 kilometers in the x direction and -2 kilometers in the y direction, then each hour I change by this amount, so I can find it's literally the distance I travel over 1 unit of time. Right, show the course of the two boats meet at the coordinate 2, 7. So if the courses meet at 2, 7, that means that I have a solution. And notice that it says show, it doesn't say verify. So we need to set our equations equal to each other, that in the x direction, -1 plus 2t needs to equal 0 plus 2s, and then in the y direction, 10 minus 2t needs to equal, let's see what we get here, 4 plus 3s, right? If we add these up, I have 9 is equal to 4 plus 5s, so therefore I know that s is going to be equal to 1. Right? And if s is equal to 1, right, then the Padge ends up at the position 2, 7. And if s is equal to 1, right, we have 2 times s is negative 1 plus 2t. So we know that that would mean that t would be equal to, let's see here, 2 times s is 2, right? So plus 1, that's 3. So t would be equal to 3/2, right? And so that means that the rab is going to be at position, let's see here, negative 1 plus 2 times 3/2, that's going to be 2, and 10, right, minus 2 times 3/2, that's going to be 7. So therefore, right, position of 2, 7 for each, right? And we could give it as a point, coordinate point in that form as well. Right, so probably better to write it so that we don't think that it's a directional vector, right? We know that we go through the point 2, 7 for each of those, right? So point 2, 7. Right, and that's showing, right? We do the work. We didn't just substitute in to see that both of them will equal 2 and 7 to verify. Now explain why the two boats do not collide. Okay, they are not at 2, 7 at the same time, right? That the, what is it, the pad gets there 30 minutes before, right? Because if I have 1.5, 1 to 1.5, the pad gets there after an hour, while the rab gets there after an hour and a half. So light application of vectors, things can get more complicated. Notice that we did this one completely without a calculator. We should be familiar with how to do it without a calculator. If we have a calculator available, this NumWorks calculator really helps out. Very nice technology to be able to use. Thank you for your time, and good luck to you in your maths studies.